Hello, and welcome to our video, Installing Apigee Hybrid with Helm. My name is Greg Coolgan, and I am a solution architect at Google. Been working with Apigee for a long time, and some of our large customers with Apigee Hybrid. We've got some exciting updates on the installation process that we're going to share with you today. I have the pleasure of being here with my colleague and friend, Ayo. Ayo, you want to introduce yourself?
Yes, thanks, Greg. Hello, everyone. My name is Ayo Salau. I'm also a solution architect at Google here, working on the Apigee team, and I'll be presenting with Greg on our video here today.
Awesome. All right, so we're going to keep this pretty brief as an introduction. Here's what we're going to cover. We're going to cover just a quick, super brief overview of Apigee Hybrid. We're going to talk about why we've chosen Helm. We're going to go through some tips and tricks. And then, of course, we'll go through a demo install of walking you all the way through from the beginning to end of setting up Apigee Hybrid. So what is Apigee Hybrid exactly? Basically, what it is it is a runtime plane where your APIs are processed through that runtime plane, and you can host that runtime plane on any Kubernetes cluster that you want in just about any location, whether that's on-prem or in other clouds or on Google Cloud. And then there's a management plane that is used to control that runtime plane. That management plane runs on Google Cloud, and it controls your user interface, all of your analytics, logging, metrics, all of those things run through the actual management plane. But the runtime traffic, your APIs, go through the runtime plane itself. Again, this is a super brief video. We're talking about installation. We assume you kind of know what hybrid is already. But just from a high level perspective, there's multiple components that get installed when you're installing Apigee Hybrid. And in this runtime plane, you've got things like Cassandra as a data store. You've got things like our runtime. You've got pods like Synchronizer that are helping to synchronize things between the control plane and the runtime plane, et cetera, et cetera. So again, there's a lot more information in our documentation. You can go through that. There are other videos that talk more in depth about exactly what hybrid is. This is just a super high level overview. So with that, I'm going to turn it over to Ayo. Ayo, why don't you talk about why Helm?
Okay, thank you very much, Greg. So we chose our team at Apigee. We chose Helm because of a few reasons. First and foremost, it was largely demanded by our customers. A lot of our customers, we discovered, use Helm. They like it because it allows them to automate installation of various other applications in their environment. It allows them to version the applications that they deploy, and it allows them to also and it's also easy to deploy the Kubernetes objects which it creates. Helm as a tool is it's very popular in creating Kubernetes resources, and that's what the Apigee Hybrid components are, Greg, aren't they? They really are Kubernetes objects that you actually are creating when you're using when you're deploying Apigee Hybrid. And Helm Chart, since it does that very well, we chose this popular tool to perform this installation in a GitOps style approach, which it does, and it helps customers to do that. And going into a bit more detail about why we chose it, like I mentioned earlier, it's easy to use. It's a tool that is widely adopted in the industry and by a lot of our customers as well. And it's even for people who are not very familiar with Kubernetes, it's easy to install. It's reproducible. It makes it easy to reproduce the deployments of parts, of components, of objects that you're creating. So, for example, with Apigee Hybrid, you were deploying multiple environments. When you deploy the first chart of an environment, you can use the same chart to deploy environment 2, 3, and 4 in that way. So that's reproducibility. It's easy to version. It makes it easy for you to track versions of the software that you're deploying per time. If you deploy a Helm chart, if it wasn't installed before, it installs the components. But if you deploy that Helm chart again with some changes to the custom values, it deploys them with the new version, with the new changes, and that becomes a new version 2 in that instance. And like I mentioned earlier, it's for automation, right? It's easy to automate the deployment of the software. It makes it a lot faster, and which is more modern, which is more of the GitOps style approach that we have today. And lastly, Helm is sticky. Okay. Now, if we move on to the slide, with Apigee, you can't really use Helm for everything. We still have one fundamental set of objects, the CRDs. With Apigee Hybrid, we have the actual object components that get created are managed by custom resource definition files for the objects that get created. And installing these CRDs helps to just ensure that all the actual domain logic is created in the way it needs to be done, and all the components are created correctly. And because it's not available yet in Helm, that process of installing CRDs, we don't have it yet. But once it becomes available with Helm, then we'll definitely have that included as well. So just to mention that that's still a bit of a minor step that's involved, but it's another kind of a prerequisite step that has to happen in our process.
Yeah, that makes sense. And I think it's specifically upgrades, right, that Helm doesn't do with CRDs. And since hybrid is continuing to evolve, we do tend to upgrade those CRDs each time that we upgrade the platform. Is that right?
That's right.
Yeah.
Exactly. Yeah. Now, yes. So now, more specifically on this slide, we're showing you the different specific Apigee Hybrid components that have a Helm chart that gets deployed. So when you're doing a install of Apigee Hybrid using the Helm chart, these charts that we're showing here are the actual components that you would get in the actual component charts that you would be installing: Apigee operator, data store, telemetry, Redis, ingress manager, org, environments, virtual host, and we have one also for the data store data replication when you're doing a multi-region scenario for your setup. Okay.
Awesome. Thanks, Ayo. That was a great quick overview. Now let's just talk about a couple of tips and tricks, and I'm going to ask you a few questions here that we can use for people as they're installing Apigee Hybrid. So how do I know that it got deployed correctly?
It's a good question, Greg. So to know that how it's deployed correctly, as part of our public documentation for the installation with Helm chart, we have a sort of verification step when you go through installing each of the component charts that we had in the previous slide. After you run each of those commands, Helm CLI commands, to install each of those charts, there is a verification step that you can perform to show that the components chart is running and that the actual custom resource that controls that chart is in running state. And you can also verify and validate by checking the pods for the corresponding chart and objects are in running state as well. They may take a while, they may take a couple of minutes, but they eventually get into running state. So I would suggest being patient, observing them till they get into a running state and you confirm that everything is fine and running and move on to the next chart.
That makes sense. And I think it's important to make sure, right, try to make sure that the step you're on is working before you proceed to the next step. Because sometimes that will cause the next step to fail as well if that previous step didn't work.
That's right. That's right.
So let's say something did go wrong, Ayo. Where can I look for errors, logs, et cetera, to help figure out what's going on?
That's a good question. So typically, as you're doing the install and occasionally if something does go wrong, you can start by checking the logs of the pods that are being created. Some of them may have some helpful information. You could run a kubectl describe on the pod and looking down to the bottom at the event section, and you'll get some useful information of the state of the pod, if it was having issues pulling down the image, if it was having issues with resources on the cluster. There'll be generally helpful information there to help you to diagnose the issue. And that's one place to check. Another place to check for errors would be in your Kubernetes cluster platform interface. So for example, if you were installing Apigee Hybrid on Google Cloud, that would be our Google Kubernetes engine, which is our platform for Kubernetes clusters. In there are several menus like the workloads menu, where you can identify each of the workloads for the pods and see if there's an error with that pod when it was getting installed or when it was getting deployed. You can look in GCP Google Cloud logging interface as well to let you identify errors and monitoring and logs to see if there's any issues in cloud logging of the pod was getting created during the startup time, and also cloud monitoring as well. To also have monitoring is a place where you can do monitoring on the pods and see if there's any issues with any of your pods as well. All of these are places where you can find information and get details about that in GCP. But in other Kubernetes cluster environments like AWS EKS, Azure AKS, and Red Hat OpenShift, in their Kubernetes cluster environments, you'll be able to get more information about the state of your pods for your cluster in those environments.
Yeah, that makes sense. So, what if I'm sitting here and I'm like, hey, I really need some world-class API management, but this already sounds more complicated than I want to get into. Do we have an option for that too?
Oh, yes, we do have an option for that. So as part of Apigee, we have not only Apigee Hybrid, the runtime based platform which we spoke about, we also have a SaaS offering from Google Cloud known as Apigee X. So this is our SaaS-based offering, which involves the entire components of Apigee abstracted away as a managed service within Google Cloud, meaning the management plane and the runtime plane are all abstracted away within Google Cloud and managed by Google. So it has that part of the runtime in RPGX will be managed fully by Google. Customers would not need to have to manage this. You wouldn't have to manage this. You wouldn't have to interact with this. All you would have access to have to work with is the Apigee UI in GCP, and that would is what you would all have to manage.
Awesome. And then last question for you. So I've already installed Apigee Hybrid, and I've used Apigee Cuddle. I'm familiar with that kind of method of installing. What's different? What should I expect? Is there anything different here with Helm?
This is also another good question. So between Helm and Apigee Cuddle, the experience is slightly different, but the resulting outputs in terms of pods, custom resources would still remain the same. One thing I would like to mention is, from a different perspective, is the introduction of automation, like we mentioned earlier, easier ways to install and version and manage, and also perform day-to operations using the Helm chart approach is something that is a significant difference that you can expect. One thing that is still the same is the use of the overrides file. In Apigee Cuddle, you would remember that we had one override file where we have all the configurations in there, and that is where you refer to that custom values, that file, for the custom values that will be deployed into your cluster. With Helm chart, you can also use the same overrides file as well to deploy your Apigee Hybrid environment. So that's a bit of the differences and some similarities that we have there.
That sounds great. So if I'm already familiar with Apigee Cuddle, I'm maybe ahead of the game already, which is awesome. All right, with that, thank you very much, Io. Let's go ahead and get started with the demo.
Sounds good.
Okay, now let's get to the demo part where we kind of walk through the installation of the Apigee Hybrid runtime. I am going to go through this relatively quickly. I'll point out a few things in the documentation as we go through, but certainly we're not going to read these docs as we go through together. I highly recommend that you take a look at the docs before you get started, kind of get an idea of all of the things that you need to do. I'm also not going to cover all of the prerequisites, so you want to definitely do that. Again, take some time to cover that, and we'll go ahead and get started. So first things first, one of the prerequisites, of course, is that you do have gcloud, the gcloud CLI installed in your shell. I'm using Cloud Shell, so super easy. It's already installed. I'm ready to go. And then the next thing you'll see here is that there are several exports that we're going to do as we go along the way. What I usually do with these exports is I actually, as I create them, I go ahead and drop them into a text file or somewhere else that I can store them. And that way, if I stop, or if I need to come back and restart my shell, I can restart and just grab all of these things and paste all of the exports for all of the variables that we use for the scripts and things like that, and get going really super easy. So you see here, I already went and clicked on this, and in our docs, you can edit and actually put the name of your individual things in, and that makes it super easy to then copy the command. And if we go over to our shell, we are going to go ahead and just paste that, make sure we've got our project ID set, which we do now. And then we'll go back to the directions here. And the first thing we're going to do is run a gcloud command to enable all of these APIs. Now, to be able to enable these APIs, you are going to have be an owner of the project, or you'll have to have specific rights to do that. If you don't have either of those things, you may need to create a ticket or something else and have your cloud team go ahead and make sure those APIs are enabled. So there we go, that's done. We go through it, we could list them. I'm not going to list them, but you'll see. So our next thing is to actually create an organization. An organization in this case is the Apigee organization that we're talking about. It's the top level container that everything fits in, nothing shared between Apigee organizations. But this is the first thing we need to do is go ahead and create that. So we do need to get an access token. This is just going to get a token that I can use to make API calls to go ahead and create that. So let's go get an access token. All right, so now we've got that token set in a variable. We'll come back here, see what else we need to do. So a few more exports that we've got here. Their org name is going to equal our project ID. That's actually something that has to be the case. So whatever your Google Cloud project ID, that will be the name of your Apigee organization. We do have to select the analytics region. In this case, you just want to select the region that's closest to you. I'm going to select US West 1. I'm in Portland, Oregon, so that's the closest area to me. And then the runtime types are important. In this case, it's hybrid. If we were setting up ApigeeX, that would be something different. We are setting up hybrid, so the runtime type is hybrid. And then what we come down to here is basically we're going to use curl to call the API, the Apigee API, and actually set up the organization. So let's go first things first. I'm just going to go ahead and I'm going to select all of my exports here, which we'll use for the rest of the time as we go through. Set those up there. And then we're going to come back over to the documentation. And we're going to go ahead and copy this command. Super straightforward. All right, let's go here. We'll paste that. And what you'll see there is that I already have this setup going. So it already exists. I don't have to do it anymore. But if that was not the case, we would get a response with a long-running ID. We can come back and check. It usually takes a few minutes to go ahead and create that organization. All right, so once we've got the organization created, so here it talks about the long-running operation ID, etc. It's all here in the documentation. There's some different ideas there if we have a problem creating things, but once we have the organization created, we can go ahead and create an environment group. I'm going to show you how to do that. We're going to do that in the Apigee UI. We're going to create an environment group. We're going to create an environment, and we're going to add that environment to the environment group. So let's switch over to our Apigee UI. So if we go here, the way to get to the Apigee UI is to go to the Google Cloud Console, and then you can search Apigee. I'll go ahead and click on that. It will take us to the Apigee homepage on the Cloud Console. We're going to scroll all the way down over here on the left and go to Environments. We're going to say, okay, let's create an environment. And I'm just going to call this environment test. I'm not going to add anything else in here. There's some things in here that you don't really need to worry about too much. And that's it. I'm just going to call it test. I'm going to say create. This will take just a second, not too long. And then I'm going to go back and I'm going to look at our environment groups and I'm going to create an environment group. I'm going to call this test group. Here we have to put a host name in that we're going to use. And I'm going to call mine test group at yourdomain.com. And we can select our environment. In this case, I want test to be in the environment group. You can learn more about environments and environment groups by Googling that and looking up the documentation. And we'll go ahead and create that environment group. So we now have an environment group that's called test group. And inside of test group, we've got an environment called test. All right, so those are all of our project and org setup steps. Now we're ready to go and start the Apigee Hybrid runtime setup. We are going to use Helm-based setup, of course, today. So let's start with our first thing here, which is create a cluster. So a couple of things that we want to check when we're creating our cluster. So one of the things that we want to check is sort of the prerequisites, the supported platforms, etc. You can come over to this page to see what we support and our different versions. We are installing 1.11. We are going to be installing on Google Cloud today. And so we support 1.25, 1.26, and 1.27. So we need to make sure that our Kubernetes cluster is one of those versions. And then we can go ahead and actually create the cluster. One other thing I will point out here, we create that cluster in 2 node pools. So we've got an Apigee data node pool, which is going to run all of our Cassandra database nodes. And we've got our Apigee runtime, which is basically going to run all of the stateless nodes, basically anything else that we're running. So I'll show you how we do that using GKE. And then finally, if we go along down here, you will see that there are some minimum requirements for the cluster. Oh, it's right there as well. Right where we were looking, we're going to create a regional cluster, which is what we recommend, and we're going to have the minimum number of nodes and the minimum size system here as we go ahead and get this started. So this just, again, just tells you the minimum size cluster that you need to create to do this. It's not necessarily, this is a production cluster. This is certainly good for a non-prod dev, things like that. Production cluster, depending on your traffic, you may need a bunch more. Now, these docs show you how to do everything with gcloud, but we're going to go through and I'm just going to show you how to use the Cloud Console to go ahead and get this done today. Oops. So we'll go back to the Cloud Console, minimize my shell here, and we are going to create a cluster. So I do not want this to be an autopilot cluster, actually. So I want to switch to standard cluster. Switch to standard. We do not support autopilot clusters yet because you can't have different node pools in an autopilot cluster. I'm going to call this GK Hybrid 1. It's going to be a regional cluster. I'm in the West, so again, I'll pick US West 1. And I'm going to go ahead and we'll just use the regular channel for today. It's 1.27. That'll work fine for our purposes. Now we want to go to the node pools. I'm going to make a couple changes here. So we've got a default node pool. I'm going to make this one Apigee runtime. And I want to go to the nodes. And again, we said that we wanted 4 vCPU. So I'm going to go with E2. That's fine. But I want to go to an E2 standard 4, which will give us plenty. And then we do want to create another node pool. So let's go ahead and add a node pool. This guy is going to be Apigee data. Again, we want to go to the nodes. And same thing, we're going to do E2. We're going to do an E2 standard 4 node on this. That's all we need to do. Now we can go ahead and click create. I will pause the video here and come back in just a second. Okay, we are back and we've got ourselves a Kubernetes cluster. It's all ready to go. We're going to use that to install later and do some things with. But for now, the next step is going to be to actually pull the Apigee Helm charts. This is pretty straightforward. It should only take a second. Goes through and suggests a directory structure for you to go ahead and use. I've got that created already. And then literally it's just a matter of pulling the Helm charts from the repo. Again, if you can't pull directly from your shell or whatever, you can get these ahead of time from somewhere else. But let me first just show you my directory structure. So here you'll see that I've got the hybrid version that I'm installing and then a Helm charts directory. Of course, I just highlighted and copied those, so I need to go back here and copy this again. We'll do that. That should pull all of the charts. And then we'll have all of the charts available. That's done. So now we go on to step 3, which is basically just creating the Apigee namespace. Super easy to do. So we'll go ahead and copy that. Now, when we're here, we need to connect to my Kubernetes cluster. Super easy to do here. I can just do connect. I can even say run in Cloud Shell. That will connect me right up to my cluster. And now I can do well, we're checking to see if the namespace is there. It is not, of course, we have not created it. And so since it is not, we're just going to go back to the docs, copy that command, super easy, and we will have created the namespace. So what's our next step? Our next step is going to be to set up the service accounts. Now, this is where I'm going to vary just a little bit than what our instructions are here, because I think this is a little easier to do, a little easier way to do, and also a little more secure. So first of all, let me briefly talk about workload identity. If you are installing on GKE, you can use workload identity. That means you don't have to have service account keys associated. A great way to go ahead and do that, but we're not going to cover that. You can certainly follow our instructions to use workload identity if you're installing on GKE. Since we're trying to make this a little more agnostic, we're going to go ahead and we have to use service account keys to actually do the installation. We have a script that will allow you to create the service accounts. So we're going to go ahead and we're going to run that script to create the service accounts. In my case, I've got it copied off here because I'm going to put it into an actual service account directory. What you'll see is if you do want to use the files for the service accounts and not use secrets, that each JSON file will have to live within its individual Helm chart directory. That's a function of the way Helm works. And that's what our instructions tell you to do. But again, I'm going to show you how to use secrets. So first thing you want to do is go ahead and run our script that will allow you to actually create the service account. I didn't actually copy that. I'm going to go ahead and have it generate new keys for me. So it's just going to go ahead and update all the IAM policy. I'm using the non-prod. So there's two different ways to do this. One, you can use prod, where you've got different service accounts for each of the things that need access. That would be recommended for a prod environment or a more secure environment. I'm going the easy route, and I'm basically creating a single service account that has all of the permissions that we need to get our job done. So what you'll see now is that there should be a service accounts directory. If I do an ls on service accounts, you'll see that there is a JSON file that has my key inside of it there. So now what we're going to do is we're going to go ahead and we're going to create a secret for using this service account. And I'm showing you that secret, that command to create the secret here. I'm going to pause there just for a second because this isn't in the docs as such through our standard documentation. We're going to go ahead and run that. And we've created a secret called apigee-non-prod-account. And we're going to actually configure that in our overrides later. But for now, that's all we need to do with service accounts. So let's go and see what our next step is going to be. So we're going to create TLS certificates. Again, you can use files here to create the TLS certificates, but I'm going to go ahead and use a secret again. Our instructions will walk you through how to do this with files. Totally fine. I'm going to go ahead and create a secret just because I think it's a little more secure and I think it's an easier way to get that done. So if we come back here to my stuff, I've already got some things here. So create a certificate. I'm going to create a certs directory. And then I'm going to do this is just going to be a self-signed cert. You might not want to use a self-signed cert, or maybe you do if this is just a POC. But for our purposes, I'm just going to use a self-signed cert here. Let's see, it executed the wrong command there. Keep forgetting to copy here. There we go. All right. You'll see that I now have a certificate and a private key. We're going to create a secret using that. And here, if we come over, here's our cert secret. It's a little different, this command, to go ahead and create that secret. But we're going to do that. All right, we have set up a test-group-ingress secret that will be used for our ingress for the certificate and the private key. Okay, moving right along. What's our next step? So we're going to create the overrides. Now, this is a step you're going to want to spend a little time on. I'm not going to go through all of these different configurations and all the things. You can go ahead and configure this overrides here. Again, you can edit all of the things and copy right from here. This overrides, by the way, is set again to use not secrets, but actual keys for your service accounts that sit on the file system. I'm going to show you our overrides. It's actually a pretty easy way of doing it and what it looks like. So let me go back to my text editor here. And let's take a look at our overrides.yaml. So let's just kind of super quickly go through this. Instance ID, this is going to be a unique instance for every cluster that you install. And usually you're installing one cluster per region, but you want this to be unique per your cluster that you're installing. So if you were to install 2 clusters in a single region, each cluster would have its own instance ID. Namespace, Apigee. You could change that to something else if you wanted, but it's generally Apigee. Here you're going to give us the your project ID, the closest region to where your analytics are running, or US West here. Excuse me, that is where your analytics are going to run, the US West one. Give us some information about your cluster name, its region, the name of the org. We're talking about the environments. You recall we'll set up an environment called test. So here's where we're talking about now using the secret. So we say service account refs, and I'll show you here. This is all, let's go back to the documentation real fast. And if you come down here, there is this reference section, and there's a configuration property reference here. And if we go to the configuration property reference, what you'll see is that all of these configuration properties in the overrides are documented here with how to use them, etc. So that includes how to use the secrets. But let's go back to our overrides. So what you'll see here is that we've got the service account refs, and we're saying, hey, look, all of these are using the Apigee non-prod secret, Apigee-non-prod account, which is the secret. And we're configuring Cassandra, ingress gateways, our virtual host, which is test group. Test group ingress is that secret that we created up, or that we created before. Again, we're using the SSL secret here as opposed to a file. And then for each of the different components that need a service account, again, just service account ref, and we're giving the name of that Apigee-non-prod-account secret. So that's what our overrides looks like. And what's our next step? It is to enable synchronizer access. So what this is saying is basically saying, hey, this service account that you've set up to use a synchronizer, which in our case is just the overall non-prod service account, is able to access able to access this particular organization. And you're basically saying, hey, it's okay to do this. This is the service account, and it's fine for them to access. Synchronizer is the component that pulls down all of the configuration for your proxy deployments and things like that to your actual runtime plane. So again, you'd follow all of these different commands. I think I have this one in my text file. Yep. So I'm just going to go ahead and use this. You have to figure out the exact name or email of your service account. There are instructions to do that, but I've already got this filled out here. So I'm just going to copy this. And I am not authenticated, which means that's fine. That's cool. I need to go back, and my token has basically expired is all that's telling me. So we need to go ahead and get my access token again. Now let's run that synchronizer command again. And basically it's coming, I've already set this up. So it's coming and saying, okay, yeah, everything looks good. That's what the response would look like here, just to kind of show you. If it wasn't, you'd get another long running operation ID here back, and your response would say something like in progress. And again, in the instructions, it tells you how to watch and wait for that to actually be all set before you proceed to your next step. And then the final step that I'm going to cover today is installing Cert Manager. There are a couple ways to do this. You can actually use Helm to install Cert Manager as well if you like, but we're just doing the super simple kubectl apply with the Cert Manager YAML that we pull from the internet as we do this. So let's go ahead and run that command and get Cert Manager running. Yep, and that's it. Again, you can check to make sure that Cert Manager is running. And you'll see that it's running. You can see those 3 pods. Everything looks good with Cert Manager, which means that we are on to our next step of actually installing the runtime. And for that, I'm going to leave you in the capable hands of Io.
I hope you're doing well today. I'll be continuing on the installation of Apigee Hybrid 1.11 from where my friend and colleague Greg had left off. The main steps I would run through from our docs today would be step 9, installing the CRDs, the custom resource definitions for Apigee Hybrid. Step 10, checking the cluster readiness. And step 11, installing Apigee Hybrid using the Helm charts. So let's dive in. You would recall that Greg had installed Cert Manager on the cluster, right? So I'm going to my terminal. He had installed Cert Manager on the cluster. So if I run kubectl on the command kubectl get cards -n Cert Manager, I should see them up and running nicely, which they are. and I see the pods. Okay. Next, I would then need to go to the home folder, similar to what I have a similar structure to what Greg has. Here, go to hybrid 1.11, and here I've created a Helm charts folder, and in there I've created my overrides.yaml file and the vars.txt. Now the vars.txt file, I have created that file similar to how Greg has sourced his variables. I've just put everything into a file, and when I just run source vars.text, I have all those variables there. And if I do an echo $org_name, I see that it's there, so that's fine. So I have all my variables. Now, to go ahead with step 9, which is the step where I install the CRDs, the first thing I'm required to do from this step is I run those commands from within the Apigee home charts home directory, which is where I am in here, Apigee home charts home directory, and I've sourced that, and I run them from this command. And the first thing will be to do a dry run install by following this command to do a dry run install of the CRDs. Now, before I do this command, I need to go back to step 2 and download the Helm charts into my own folder, right? I need to download them back down into my shell as well, as Greg had them. So let's just do that. So to do that, we'll be basically pulling them from this OCI repository where you have them. Since I have my folders, I just come right here to pull the Helm charts for 1.11, copy that set of commands, and when I copy this here, I will have all the Helm charts being pulled into that folder right there. Okay. Just wait for that to complete. So now that I've pulled the charts, the simple ls from here will show me all the Apigee chart folders that I have in there. Apigee chart folders: operator, data store, environment, ingress manager, org, Redis, telemetry, and virtual host. So these are all the Helm charts that we'll be installing today. And now that I have pulled them down, I can then now go back to step 9 and install the CRDs that will be required manually. As we mentioned in the earlier video, the CRDs is still a bit of a manual step that we need to follow for now before the automation, because Helm it as a tool doesn't support CRDs yet as of now, and it's something that's required by Apigee Hybrid. So we'll just run this step manually. So I'm going to just do a dry run as required. Okay. Now while that's happening, we see that several dry run is coming up one after the other, and everything is done. So now I can do the actual command after checking that installation, and now install the CRDs with this command. Okay. Let's clear that up. The next thing I need to do will be to validate this installation of the CRDs with the kubectl get CRDs command, which I'll copy that and then put that here. And we can see that, yes, all the CRDs are there: Apigee data store, deployments, environments, organization Redis, and all they're all there. Okay. Now that I have the CRDs, I have the output looking similar. The next step is to check cluster readiness. So we can now move to step 10. Okay. Now we're going to check hybrid cluster readiness. Basically, we're going to check that the Kubernetes cluster that we've created is ready. Everything is working fine. All the kube system and all the components are up and running. The node pools and all that's required are available. So basically, to do that, we're going to create a YAML file and verify that the kubectl is using my correct context. Let me do that first. Okay, it is. So I can say now, basically create a YAML manifest file. I'm connected to my cluster already because when I run the kubectl commands, I get a response. So I first create a cluster check directory as mentioned here. So I can just do this. Okay, so that's done. And then in that cluster check directory, I create a file named apigee k8 cluster ready check.yaml. So copy that. So I'm going to go into the cluster check folder, which I just created. Okay, and let's create that file that the document has asked me to create. So in here, what we're really creating is creating two Kubernetes objects: a service account named Apigee Kubernetes cluster ready check, and a batch job, right? Which will basically check the status of the cluster, like I mentioned. It will check a few things, basically check the containers and do some checks to make sure that the cluster is set up correctly. come in here, put that in. Okay, so now that I have that in there, the next thing I need to do is to apply that, right? And that will run the test on the cluster. And what it will do, it will create those two Kubernetes objects for me, the service account and the batch job, like we mentioned. So now that it's done, I can now check the next step. Step 5 is to check the status of that Kubernetes job with this command. Switch back. Okay, so it's running. It's been running for 16 seconds, and that's the service account and the job, and then the job, and then it's ready. We have the output. Then now that we know that we have that has been running, and we have one completion, meaning it was successful, the next thing is to do the cleanup. This test success, so we don't have to check the other things. So clean up before proceeding to the next step. So I'll just delete that job by running this delete command, and it's gone. Okay. So basically, we've now completed step 10 of some bare metal test. Now we can go to the last step, which is where we install the actual Apigee Hybrid. Install Apigee Hybrid using the Helm charts, actually. Okay. Now step 11, and here, similar to the charts that we pulled down, these are the components. Each of the Apigee Hybrid components have a chart that we'll be installing here. Okay. All right. So now the first thing to do will be to do a dry run of installing the Apigee operator. Installing the Apigee operator. Many of you might remember with Apigee Kotl, we would typically do Apigee Kotl init, do a dry run, or Apigee Kotl apply, do a dry run. But similarly, we're doing for the operator, we're going to do a dry run command, dry run for that as well. But before doing that, I would like to, I'll go out of the cluster already. I would like to just take a look at the overrides, show everyone that we have that, and it's nice, looking nice and neat. So here's my overrides file. So just starting from the top here, I have here the instance ID, the namespace, Apigee, the cluster name, GCP project ID and region, the org name, environment. My environment, one environment here is test, similar to what Greg had. And also I have here my service account secret reps configurations. And under Cassandra, host network is set to false because we're only setting up in one single region installation. Doing one single region installation with one replica pod for Cassandra. This is a non-prod setup, so one pod is fine for the Cassandra database. Ingress gateway, setting the name to ingress-1, and then virtual host test-group, and everything else is there. So under the org level, the components, smart, connect agent, logger, metrics, UDCA, watcher, they're all there, and it looks good. So now we can proceed to do the dry run of the Apigee operator using, not the test, using the Apigee operator command, okay, for dry run. So here we go. So we should see that go successful in just a minute. Okay, so that ran fine. Okay, next that ran fine. So now we can actually do the actual installation of the Apigee operator chart, which I run with this other command. Okay. So it's installing the Apigee operator, and remember that with Helm charts, if when we install Helm charts, one of the benefits of installing it with Helm is if it's the component is not there, is not created previously, it will install it newly. If it's already there, it will create a new version of it, of the component that's been, of the charts and Kubernetes objects that have been installed. In this case, it wasn't there, so I'm having revision number 1 in here, the first revision of this Apigee Hybrid Helm chart named operator. So that's installed. And how do we check this? How do we validate this? We verified that it was the Apigee operator installation by running the command helm ls-n Apigee. That will show us Apigee system. This will show us what's created in the Apigee system namespace. So it does two things. When you install this chart, it creates the Apigee system namespace, and it then creates this operator chart, and it also creates the pods in there. So here, if I do kubectl to verify that that chart is up and running and check the availability, I'm going to run this kubectl -n Apigee system get deployment to get the deployment in the Apigee Apigee controller manager deployment, and I can see that it's up and running. Okay, so it's there. The next component that we install is the data store. So I'll just do a dry run of that first, as in that document. Okay, that went fine. So I know that the installation would go fine as well. So here's the one for the data store. Okay, so it's not there and it's installing it, and I have version 1 for data store. Now let's validate that it's there. The data store itself is actually running. Validate with that, and I see it in a creating state. Okay, so at this, we'll wait for that. So here, after Apigee data store, the next thing I'll need to install will be telemetry, and then after that would be Redis. After that, after Redis would then be Apigee Ingress Manager, and after which would be the Apigee org, and then the Apigee environment, and then after the Apigee environment, and then I need to install the virtual host. Virtual host, we install that with is basically the environment group, which is which is the virtual host that we'll be installing, and I'll put in the environment group name here, and then that would do that installation, and that would be all that I would have to install for today in this video. If we take a look, we would see that the Apigee data store is up and running. It took 2 minutes and 46 seconds. And when I look in Apigee data, Apigee namespace, I can see that the Apigee Cassandra pod is up and running, which is nice. Okay, it's good to always wait and make sure that that's completed before we proceed. So now that that is running, the next thing after the inner docs, after data store will be, and we've validated that data store is running, will be to install Apigee telemetry. I'll do a dry run of telemetry. Okay. And then I can install it. And we see that gets installed. Okay. I can verify that the telemetry component is in running state. Okay, that's also creating. So telemetry and logger pods are up and running. So we can proceed then. The next step after telemetry is Redis. Okay. So now we're installing the Redis chart. Okay, that's running. And now if you check the pods, and it is in running state. Okay. So just a little validation on the Redis. Verify that the Redis component is there. Okay, it's running. Okay, and then Apigee Ingress Manager will do the same. First to do a dry run, and then install the actual chart. Okay, now that Ingress Manager is installed, let's verify it's up and running. Okay, that's up and running. The next will be the Apigee org. Now, what's my org name? I remember that our org name is the same as our project name, which in this case is Apigee Hybrid Setup TMP1. So I'm just going to copy that in and put it in here. Okay, that was the dry run for Apigee org. I'm not going to install it. Okay, and that's there. So now I have my Apigee org installed. Let's verify that it is up and running, and I do that with this command. So after Apigee org, the next thing is to install the environment and the environment group, and that will be it for today. The pods are up and running, and it will eventually come up. But at the point where we can proceed. So now the next thing will be to install the environment, and you would recall that the environment name is test. So I'll just do the dry run first for test. Okay, so now you can see that March has completed, and we see here now runtime and synchronizer pods are in initializing state and are coming up. So remember that when you're setting up an environment in Apigee Hybrid, the environment typically uses the runtime and synchronizer pods. That's how you identify each environment. So for every environment that you create in your Apigee Hybrid cluster, you would have a runtime and synchronizer pod for that environment. So that's getting created. So we'll just wait for that to get into running state before we proceed. It's already in running state. Okay, before I pivoted. So what we're waiting for now, we can now move into the environment group, which is the last thing. And its test group is the name of my environment group. Here, I do the dry run for the environment group. That works. And then now I can run install environment group. Okay, so that's done now. So let's check the state of. So the environment group, really, when you create that, it creates two things: the Apigee route config and the Apigee route. So let's just double check that we have those. Just static resources, really. Apigee route config, I think it's Apigee route. Yeah, so we have those. Both of them are up and running, which is nice. So with that, congratulations, you successfully installed and configured Apigee Hybrid Runtime. We look at all the pods again, just for another visual check. You can see that everything will be up, should be in a running state. Yes, and everything is up and running. So with that, we have completed the installation of Apigee Hybrid on our cluster, and there you have it. So thank you very much for everyone. Hope you enjoyed this video, and enjoy the rest of your day.